So here are some of the questions which were sent to me. So the first question is, find the equation of the tangent and the normal to the curve, to this curve at the point 1 comma 1. So basically there is a curve, and at the point 1 comma 1 there is a tangent drawn and also a normal drawn, whose equations you have to find. So what do we know to do is, we know to find the slope of the tangent with the help of this curve. Okay, that is how, by finding the dy by dx, we'll get the slope of the tangent. Okay, with that slope and 1 point on the tangent, I will be able to find the equation of the tangent. Now, slope of normal is nothing but a line which is perpendicular to the tangent. So, slope of the normal will be minus 1 upon slope of tangent. Okay, and then the same point 1 comma 1 lies on the normal also. So, with that help, we'll find the slope of the equation of the normal too. So, let us begin. Here we have the equation of the curve. We differentiate with respect to x and we get this minus y. Be careful differentiating this term. It is uv. First I differentiated x term. So 1 into y minus, now y term I have to differentiate. So x I write as it is and dy by dx plus y square is 2y dy by dx. I have directly equated it to 0 so that I find the value of dy by dx. Okay, so I've clubbed together this and all the dy by dx terms. This and this together give me 2y minus x. Okay, so take this the other side. Okay, and take this down here, you get this. Later, next step, you have got now dy by dx as this, right? And this is the slope of the tangent. Now I want to find the slope of the tangent at the point 1 comma 1 specifically. So I substitute the values of x and y and I get my slope, which is minus 5. So given this slope, given m is minus 5 and point which is 1 comma 1, I will use the standard equation of a line formula and substitute. Y naught is nothing but 1 and x naught is also 1. And my equation should be in terms of x and y, so these are the general points on the line, okay, that you will not substitute. So y minus 1 equal to slope minus 5 into x minus 1. So finally this is the equation of tangent. Equation of tangent. Okay, now we have to find equation of normal. Slope of normal is nothing but, what is normal? Normal is a line perpendicular to the tangent. Okay, so this is my tangent and this is my normal. So normal slope is minus 1 upon slope of tangent, which I've already told you all. So minus 1 upon minus 5 is 1 upon 5. So this is my slope of normal. Okay, now next. Since the tangent and the slope are drawn at 1 comma 1, from 1 comma 1, which lies on the normal with slope 1 upon 5, that is we have on the normal a point plus the slope is given. So directly use the equation of line this. Okay, but now you're finding of the normal, so slope value will be the slope of the normal, which is 1 upon 5. Okay, but the point will be same, so this is finally your equation of normal, and hence we have solved the problem. Second problem was this. Okay, find the interval in which this function is increasing and decreasing. So usually the first steps are f dash of x. Second step will be f dash of x equal to 0. Third step will be find x, okay, all the points. And the fourth step will be mark on number line, okay. Fifth step is find intervals, and sixth point will be find where increasing or decreasing. So these are the steps. Okay, so the first step is done by me. Okay, now you have to be very careful while differentiating this term, because this x plus 1 the whole square is my u, and x minus 2 the whole square is my v. So I have to use the uv form and differentiate. Sorry, the curve is here. So this is my u and this is my v. So derivative of u is 3x minus 1 the whole square into v, okay, plus derivative of v. So v derivative is 2 times x minus 2 and into u. Okay. So later we are going to just simplify it by not opening the brackets but rather taking out the common brackets. So x minus 1 the whole square is here and here also. So I took out square term and just x minus 2, because here there is no square. Whatever remains I've written the bracket, opened it up and got this third bracket. Okay, now first step is done. Second step is equate it to 0, which is done here, and hence when you equate it to 0, this bracket will give me x equal to 1, this bracket will give me x equal to 2, and here x equal to 7 by 4. Okay, here it is square term, so remember x I will get 1 twice. Okay, 1 comma 1 like that. Okay, so find x is also done. Next step, you have to mark on the number line. So let me draw the number line for you. The number line is looks like this. Okay, we have 1 is first, 1 is here, then is what is 7 by 4? 7 by 4 is nothing but 4 ones are 4. 1.7, which is before 2. So 7 by 4 will be here and then will be 2. Okay, and this side is infinity and minus infinity. So basically the intervals will be minus infinity to 1, 1 to 7 by 4, then 7 by 4 to 2, and 2 to infinity. Okay, so these are your 4 intervals. Now next is your sign convention. Okay, sign convention I told you all to start with plus on the extreme right. So plus here, minus here, plus here. But now just remember, I had told you whichever bracket has square, that around that number you will repeat the sign which was before it. So since it is plus, I will write here plus again. Why? Because it is square. The number 1 is repeated twice. Okay, now this is done. After this, you are going to find the sign of f dash of x. Okay, write the intervals here: minus infinity to 1, 1 to 7 by 4, 7 by 4 to 2, and 2 to infinity. Okay, so according to the sign there was plus here, so overall increasing, f of x is increasing. Here I got also plus, so f of x is increasing. Then I got minus, so f of x is decreasing. And here I got, sorry, plus again, so f of x is increasing. So overall, which intervals f of x is increasing? F of x is increasing in minus infinity to 1 union 1 to 7 by 4 union 2 to infinity. Okay, and f of x is decreasing for 7 by 4 comma 2. Okay, now there is one more way you can determine the sign of f dash, that is without considering the sign convention and actually taking values between the intervals. For example, the number which lies between minus infinity to 1 is 0. So what you're going to do is, you're going to put 0 in place of this. Wherever x is there, you will put 0. So if I put 0 in place of x, this bracket is going to give me minus 1 the whole square. This is going to give me minus 2, and this is going to give minus 7. So total it is 1 into minus minus plus 2 sevens are 14. So this is greater than 0. So it is positive. Sign is positive. So it is true that f dash is positive here and f of x is increasing. Similarly, now your next interval is 1 to 7 by 4. So you can take around 1.2. If you take 1.2 here, you will get 0.2 the whole square. Then here you will get a negative answer because it's less than 2. 1.2 minus 2 is obviously a negative number, and here 4 times 1.2 will be 4.2 minus 7, still a negative number. So overall it is a positive number. So still this is correct what we have done. Okay, now your next interval is 7 by 4 to 2. So you can take some number just before 2, that is 1.9. Okay, 1.9, and check it out. Similarly, from 2 to infinity, suppose you can take number 3 and check. Okay, this is the second method. So we drew the number line, found the intervals, find decreasing. So this is done. Now, next question is the normals at A and B on the curve x y square is equal to 16 pass through the origin. Find the coordinates of A and B. Okay, so I have to find the points A and B. Okay, and these are normals at there are normals, that is there is some curve, there is a point A and B here. Okay, and through that point normals are drawn. Okay, and these normals, this and this, they pass through the origin is nothing but 0 comma 0. So given this information, let us start. Okay, what we always know to do first is find dy by dx. Okay, so first we'll differentiate this equation. Okay, y square is equal to 16x I did, and then I've differentiated both sides. So 2y divided by dx, and 1 upon x, its derivative is nothing but minus 1 by x square. So that I have written here. Okay, so keeping dy by dx one side and taking all the others the other side. Okay, now you have to find slope of the normal. Slope of the normal is nothing but, I had said, minus 1 upon slope of tangent. Okay, and slope of tangent is what? Minus 1 upon slope of tangent is dy by dx. So I have found dy by dx, that is this value. So I'm going to put this here, and that's what we have done here, and hence I got the value x square upon y, x square y upon 8. Now this is the slope, and the normal passes through the origin. So I have one point and one slope. So slope and point are enough to find the equation of the line. So I find the equation of the line. Okay, and the equation of that line is this. Okay, and then what I do is, on that line, on that normal, there are coordinates which I want to find, okay, which are passing from the origin. So I take out y common. See, there is 8y minus x cube y. So y is common both sides. So I take out y common. 8 minus x cube equal to 0. Equate y to 0 and equate 8 minus x cube to 0. You get 8 is equal to x cube. What is x? X is nothing but 2. Okay, so when you get x equal to 2, you have to substitute that in your original equation, which is x y square is equal to 16. So y square is nothing but 16 by x, and x is 2. So that I've done here. So y square we got 8. So y will be nothing but the square root, that is plus or minus 2 root 2. So when x is 2, my other coordinates are, y coordinates are the 2 comma root 2 and 2 comma minus 2 root 2. These are my a and b. Okay, so this is found. Why didn't we use this? You will say, suppose I use this y is equal to 0 and put it where in this equation. So let me do that. Okay, y0 x into 0 is equal to 16 will give you x is equal to also, let me write it properly. Okay, I want to find value of x. So x equal to 16 by y squared. Y is 0. So 16 upon 0 is not defined. Okay. So hence we are not considering it. So these are my A and B, and the problem is done. We had to find coordinates of A and B such that the normals are passing from the origin. Next question. A figure consists of a semicircle with a rectangle on its diameter. Okay, or there is a semicircle, and on that semicircle there is a rectangle drawn on the diameter. Given the perimeter of the figure, the value is not given, just they're telling perimeter is of the figure. You have to consider, find its dimensions in order that the area may be maximum. Okay, so area should be maximum. So your function should be area. Okay, now let us draw. I have already drawn. It is a semicircle, and on that the diameter, a rectangle, is drawn. So what I have actually done is, I have considered the radius to be from here to here as r. Okay, and hence the diameter will be 2r, obviously. Then I've considered the breadth to be x. Now look here, the length of the rectangle is nothing but the length of the diameter, hence it is 2r. Okay, so these are all the dimensions of the figure. They have said the perimeter of the figure is given. Basically you have to just find, let P be the perimeter of the figure, and we'll find the perimeter. Now see, what is the perimeter? It is the border of the semicircle, that is half times 2 pi r. What is 2 pi r? Circumference. Its half will give you the perimeter of the circle. Semicircle. So half 2 pi r is the perimeter of semicircle, plus the perimeter of the rectangle is nothing but 2 times its breadth and 2 times its length. But now see, I have taken only once its length because the second length is already considered while taking the perimeter of the semicircle. So only once I have taken the length of the rectangle. Okay, one side of the rectangle, one length, then two breadths, that is 2x, and the rest is the semicircle. So what is in red is this box, and what is in blue here is in the next box. Okay, so this is basically the perimeter. Don't do the mistake of writing here 2 times 2r. Don't do that. Okay, it is just once. Now simplify this, cut this 2, I get pi r and this. Now what I do is, I simplify taking r terms together and 2x. Okay, now our main function to be maximized is the area. Okay, so that is why I have to find the area of the figure. Area of the figure is area of semicircle plus area of rectangle. So area of circle is pi r square. So its half will give you area of semicircle, plus area of rectangle is length into breadth. Length is 2r, breadth is x. So what I am doing now is, what I have done here is, our aim to find maximum area So basically we have to find a dash, correct? That is dA by something. And to do that, my equation here has two variables, r and x. So I convert this x and write it in terms of r. From where? From my this equation here. Okay. So P is r times pi plus 2 plus 2x. That's why. And P is not a variable, it's a number because it's perimeter. Okay, so x is P minus r times pi plus 2 upon 2 is equal to x. So that I've substituted here and I've opened a bracket. This 2 and this 2 gets cancelled. So PR minus r square pi plus 2. Okay, this is my area. So next step is to find derivative with respect to the only variable here, that is r. And after finding derivative, we are going to do what? Equate it to 0 to find the value of r. And then find double derivative. Why? Because we want to check whether the area is maximum, okay, at that given r. Okay, and double dash should be negative, then I say it is maximum. This is the one method. The second method was f dash, you have to find sign. Okay, the second method will be using here. Okay, so I have found the derivative. This is the derivative. Cancel this 2 extra, pi r plus p minus, open the bracket, 2 pi r minus 4r. Okay, so if you notice, 2 pi r and pi r is having common variable. So 2 pi minus 2 pi plus pi is nothing but minus pi r. So that is here, and rest p minus 4r. Now second step is to equate it to 0 and get the value of r. Okay. Now to find whether it is maximum or minimum, I have differentiated dA by dr, again double derivative. Okay, and I get derivative of P is 0 because it's a constant. Derivative of minus pi r is minus pi. Okay, and derivative of minus 4r is minus 4. So minus pi minus 4 is a negative term. Okay, totally. So it's less than 0. So A achieves maximum. A here is our f of x. Okay, now we have to find the dimensions also. R is already found, x is to be found. Okay, what I did, x I had removed, but it's in terms of r. So what I do is put value of r here and get the answer. So this is your x. So your dimensions are done. Okay.